Hey there, car enthusiasts. Today we're diving into the graveyard of automotive innovation with 25 suspension gimmicks that manufacturers thought were genius but turned out to be complete failures. These systems were supposed to revolutionize how we drive, but they disappeared faster than your paycheck after visiting the mechanic. If you love learning about automotive failures and forgotten technology, smash that subscribe button because we've got a wild ride ahead. Let's get into it. First up, we have Citroen's Hydractive 3 Plus suspension. Now, Citroen has always been quirky, but this system took complexity to a whole new level. It used hydraulic spheres filled with nitrogen gas that were supposed to adjust based on road conditions. Sounds great, right? Wrong. The system was so complicated that mechanics needed a PhD just to diagnose problems. When it worked, it was smooth as butter. When it didn't, which was often, you were looking at repair bills that could finance a small car. The spheres would leak, the hydraulic fluid would contaminate everything, and finding replacement parts became a treasure hunt. Owners quickly learned that riding on clouds wasn't worth the constant trips to the shop. Next is the Bose electromagnetic suspension system. Yes, that Bose, the speaker company. They decided to get into car suspension in the early 2000s, replacing traditional springs and dampers with electromagnetic motors at each wheel. The idea was to use sensors and computers to predict road surfaces and adjust instantly. In testing, they could keep a car completely level while driving over obstacles. The problem? Weight and cost. The system added hundreds of pounds to the vehicle and required massive amounts of electrical power. It was so expensive that even luxury car buyers couldn't justify it. Only a handful of prototypes were ever made, and Bose quietly shelved the project, sticking to what they knew best: making overpriced headphones. Moving on to the height-adjustable suspension on early luxury SUVs. Before air suspension became reliable, manufacturers tried using hydraulic rams to raise and lower vehicles. The Lincoln Navigator and early Range Rover models featured systems that were supposed to lift for off-roading and lower for highway driving. In reality, these systems leaked constantly, got stuck in one position, and left owners stranded with vehicles that looked like three-legged dogs. The hydraulic lines would crack from road salt, the pumps would burn out, and the control modules would fail if you looked at them wrong. What was meant to be a premium feature became a reliability nightmare that killed resale values faster than you can say, check engine light. Then there's the Mercedes-Benz Active Body Control with its curve tilting feature. Mercedes thought it would be brilliant to make cars lean into corners like a motorcycle. Using hydraulic actuators, the system would tilt the body to counteract centrifugal forces. The engineering was impressive, but the execution was problematic. Passengers reported feeling motion sickness because their bodies expected one thing but felt another. The system was insanely expensive to maintain, met with hydraulic components that cost more than some people's entire cars. After a few years and countless complaints, Mercedes quietly removed the tilting feature from later versions, admitting that maybe cars should just stay flat like they've done for 100 years. Number 5 brings us to Cadillac's road sensing suspension from the 90s. This was one of the first attempts at electronic suspension adjustment in American cars. Sensors would read the road and adjust dampers accordingly. The concept was solid, but the technology wasn't ready. The sensors would get confused by anything from potholes to sunlight hitting them at weird angles. The system would randomly switch between soft and firm modes while driving, creating a jarring experience. Even worse, when it inevitably failed, that the suspension would lock in whatever mode it happened to be in. You either got stuck with a suspension so soft you'd get seasick, or so stiff that you'd feel every pebble on the road. Owners quickly learned to bypass the system entirely and just live with regular suspension. Let's talk about the pneumatic interconnected suspension used on some British Leyland cars in the 70s. This system connected the suspension at opposite corners of the car using pressurized gas and fluid. The idea was to improve handling and ride quality simultaneously. What actually happened was a maintenance disaster of epic proportions. The system had so many seals, valves, and interconnected components that something was always leaking. Finding the source of a leak was like playing the world's worst game of hide-and-seek. British Leyland reliability was already questionable, and this suspension system became the poster child for overcomplicated British engineering. Most surviving cars have had the system completely removed and replaced with conventional suspension. Number 7 is the load-leveling air shocks that became popular in the 80s. These weren't full air suspension systems, just air-assisted rear shocks that were supposed to maintain ride height when loaded. They came standard on station wagons and trucks, and they were terrible. The airlines would crack and leak, the shocks themselves would fail, and the compressors would die. When they leaked, which was always, you'd hear a constant hissing sound from your rear end. The worst part was that they didn't even work that well when functioning properly. Your car might be level, but the ride quality was harsh and bouncy. Eventually, everyone realized that just installing stiffer springs was cheaper and more reliable. Moving to number 8, we have the electromagnetic dampers from Delphi called Magnaride. Now hold on. You might say this system is still around, and you'd be right. But the early versions were absolutely nightmarish. The fluid inside contained metallic particles that would separate and settle, requiring the dampers to be shaken before installation. Early systems had sealing issues, and the magnetary or heological fluid was expensive and difficult to replace. The control modules would also fail, leaving you with dampers stuck in whatever state they were in. While modern versions have improved dramatically, those early adopters paid the price in both repair bills and frustration. Number 9 brings us to Toyota's TEMS, the Toyota Electronic Modulated Suspension. This appeared on Supras, Cressidas, and other models in the late 80s. It offered sport and normal modes using electronically controlled dampers. The problem was that the difference between modes was barely noticeable to most drivers. The sport mode wasn't sporty enough for enthusiasts, and the normal mode wasn't comfortable enough for luxury buyers. Meanwhile, the system added complexity, weight, and cost. When the actuators failed, replacement was expensive, and many owners just converted to regular suspension. Toyota eventually admitted defeat and dropped the system, realizing that sometimes simpler is better. Let's discuss the self-leveling suspension on 80s Mercedes-Benz models, specifically the W126 S-Class. This used a complex system of hydraulic components to maintain rear ride height. While the concept was sound, the execution meant adding dozens of failure points. The level sensors would corrode and fail, the hydraulic pump would leak, and the accumulators would rupture. Owners would wake up to find their cars sitting on the ground like defeated animals. The repair costs were astronomical, often exceeding the value of the car. Many examples were scrapped simply because the suspension repair was too expensive, making this feature a death sentence for otherwise solid vehicles. Number 11 is the Nissan Sonar suspension from the early 90s. This system used sonar sensors to detect road surfaces ahead and preemptively adjust damping. It was futuristic and ambitious, appearing on high-end Infiniti models. And the reality was that the sonar sensors couldn't differentiate between actual road irregularities and things like shadows, road paint, or debris. The system would constantly make unnecessary adjustments, creating an inconsistent ride. When the sensors inevitably got dirty or damaged, the whole system would malfunction. Replacement sensors were ridiculously expensive, and the entire setup was eventually abandoned as a cool idea that just didn't work in the real world. Next up is the hydraulic suspension bushing system that Mazda tried on some models. Instead of solid rubber bushings, these used hydraulic fluid to provide variable compliance. The goal was to offer both sharp handling and comfortable ride quality. In practice, the hydraulic bushings would leak, the fluid would degrade, and the ride quality would become vague and disconnected. The bushings were expensive to replace and didn't last nearly as long as conventional rubber ones. Mazda quietly dropped this feature after realizing that engineers had been making perfectly good rubber bushings for decades, and there was no need to reinvent the wheel, or in this case, the bushing. Number 13 brings us to the air suspension systems on early luxury sedans from the 2000s, particularly on Audi A8 and Volkswagen Phaeton models. While air suspension technology has improved, these early versions were disaster magnets. The air struts would leak from the rubber bladders cracking, the compressors would burn out from constantly running, and the height sensors would fail. What made it worse was that these cars would often drop to the ground overnight, now requiring a tow truck just to get them started. The repair costs were so high that these cars became nearly worthless on the used market. A 10-year-old luxury sedan that originally cost $70,000 would sell for $5,000, and buyers still wouldn't touch them because of the suspension. Let's talk about the Williams Formula One derived active suspension that was briefly considered for road cars in the 90s. Williams Grand Prix engineering had dominated racing with their active suspension technology and thought about licensing it for production vehicles. The system used hydraulic actuators and computers to control each wheel independently, eliminating body roll entirely. It was tested in prototype vehicles, but the cost was absolutely insane. The system required constant maintenance, consumed significant power, and was too complex for regular drivers to understand. The liability concerns alone made manufacturers run away. It remained a racing-only technology, proving that just because something works on a track doesn't mean it belongs on the street. Number 15 is the interconnected hydraulic suspension used on some Maserati models. The Italian automaker wanted to offer a unique suspension feel, so they created a system where movement at one wheel affected others through hydraulic connections. The goal was to reduce body roll while maintaining compliance. What they got was a suspension system that felt weird and unpredictable, with handling characteristics that changed based on fluid temperature and system pressure. The hydraulic components were typical Italian reliability, which is to say they leaked constantly. But repair costs were stratospheric, and finding mechanics who understood the system was nearly impossible. Most surviving cars have been converted to conventional suspension by owners who got tired of the constant problems. Moving to number 16, we have the electronic air suspension that came on the Lincoln Continental in the late 80s. This was one of Ford's early attempts at air suspension, and it was spectacularly unreliable. The air compressor was undersized and would overheat. The air springs would rupture, and the control module would fail randomly. Owners reported cars that would lean to one side like sinking ships or suddenly drop to the ground without warning. Ford dealerships didn't even have proper diagnostic equipment for the system initially, so repairs were often guesswork. And the repair costs were so high that most owners just had the air suspension completely removed and replaced with conventional coil springs, which should have been there in the first place. Number 17 brings us to the adjustable dampers on 90s sports cars that used rotary valves. These appeared on various Japanese performance cars and allowed drivers to manually adjust suspension stiffness. The rotary valve mechanism would seize up from corrosion, leaving dampers stuck in one setting. The adjustment cables would break, and the valves themselves would leak. Even when working, the adjustment range was so narrow that most drivers couldn't feel the difference between settings. Mechanics hated working on them because the valves were integrated into the dampers, meaning a simple failure required complete damper replacement. Modern adaptive dampers with electronic control made these mechanical systems instantly obsolete. Let's discuss the semi-active suspension that Lotus developed and licensed to General Motors in the 80s. This system appeared on various GM vehicles and used computer-controlled dampers to adjust in milliseconds. The technology was groundbreaking, but far ahead of the electronics available at the time. The control modules would crash and need rebooting, the sensors would give false readings, and the damper actuators would fail. The system was so complex that even GM engineers had trouble diagnosing issues. After a few years of warranty claims and customer complaints, GM quietly phased out the system. Lotus, meanwhile, learned valuable lessons that they'd apply to future suspension development. But this early attempt was definitely a learning experience paid for by unfortunate customers. Number 19 is the height-adjustable suspension on the Honda Accord wagon from the 90s. Honda thought families would love being able to lower their wagons for easy loading and raise them for ground clearance. The system used electric motors and mechanical linkages to adjust ride height. In typical Honda fashion, they over-engineered the solution to a problem nobody had. The electric motors would fail, the linkages would bind, and the switches would stop working. The system added weight and complexity for a feature that most owners never used. When it broke, repair costs were ridiculous for what was supposed to be an affordable family car. Honda dropped the feature after one generation, admitting that a simple fixed-height suspension was what people actually wanted. Number 20 brings us to the adaptive air suspension on the original Audi Allroad. This was supposed to make the Allroad capable both on-road and off-road by adjusting ride height. The air springs would fail catastrophically, often taking the expensive control arms with them. The compressor would burn out, and the entire system would develop leaks that were impossible to trace. What made it tragic was that the Allroad was otherwise a great vehicle, but the suspension issues were so severe that they tanked resale values. A $20,000 repair bill on a car worth $15,000 became common. Most survivors have been converted to conventional coil spring suspension, erasing what made the Allroad special, but also making it actually reliable and drivable. Let's talk about the variable rate leaf springs that appeared on some trucks and SUVs. These used multiple leaves with different lengths and rates, supposed to provide both load capacity and empty ride comfort. The leaves would shift, squeak, and eventually crack from fatigue. Lubrication was required constantly, and the ride quality was never quite right at any load level. The systems were heavy and took up valuable cargo space. Modern coil spring and air suspension systems made these variable leaf setups instantly obsolete. They represented the last gasp of leaf spring technology trying to compete with modern suspension designs, and they failed miserably at the task. Number 22 is the electromagnetic active suspension that Nissan developed for the Infiniti Q45 in the early 90s. This used electromagnetic actuators to adjust damping rates thousands of times per second. The technology was impressive but incredibly expensive and failure-prone. The electromagnetic coils would overheat and fail, the control systems would malfunction, and the power requirements were enormous. When working perfectly, drivers reported only marginal improvement over conventional adaptive dampers. The cost-to-benefit ratio was terrible, and reliability issues made it even worse. Nissan abandoned the technology after a few years, realizing that sometimes conventional solutions are conventional because they actually work. Moving to number 23, but we have the hydraulic bump stops that some manufacturers tried using. These were supposed to provide progressive resistance as suspension compressed, using hydraulic damping in the bump stops themselves. The hydraulic seals would fail, the fluid would leak out, and the bump stops would either become rock hard or completely collapse. They were expensive to replace and offered questionable benefits over conventional progressive bump stops. Engineers realized that achieving the same effect with properly designed springs and dampers was much simpler and more reliable. The hydraulic bump stops disappeared almost as quickly as they appeared, remembered only by mechanics who had to deal with their failures. Number 24 brings us to the active anti-roll bars that appeared on some luxury SUVs. These used electric or hydraulic motors to disconnect or stiffen anti-roll bars based on driving conditions. The goal was to allow maximum articulation off-road while providing flat cornering on pavement. The motors would fail, the disconnect mechanisms would seize, and the control systems would malfunction. When they broke, you'd either have no anti-roll bar at all, creating dangerous body roll, or a permanently connected bar that limited off-road ability. The complexity and cost were enormous, and the reliability was terrible. Most manufacturers abandon these systems in favor of simpler solutions, or just accepting that compromises are part of vehicle design. Finally, number 25 is the load-sensing proportioning valves and suspension systems that try to adjust damping based on vehicle load. These mechanical systems use springs and levers to detect weight and modify suspension response. The mechanisms would corrode and seize, give false readings, and eventually stop working altogether. The adjustment range was limited, and the systems couldn't adapt quickly to changing conditions. They represented the last attempt at mechanical self-adjusting suspension before electronic systems took over. While the concept was sound, the execution was purely mechanical in an era that demanded electronic precision. They disappeared not because the idea was bad, but because the technology to properly implement it didn't exist yet. So there you have it, 25 suspension technologies that automakers wish they could forget. These systems prove that innovation sometimes means expensive failures, and that not every advancement is actually an improvement. The automotive graveyard is full of brilliant ideas that just didn't work in the real world, leaving owners with repair bills and engineers with valuable lessons. If you enjoyed this trip through suspension failure history, make sure you're subscribed for more automotive deep dives. What failed automotive technology should we cover next? Drop your suggestions in the comments below, and I'll see you in the next video. The fascinating thing about all these failures is that they weren't born from stupidity or laziness. These were genuine attempts by brilliant engineers and well-funded manufacturers to push the boundaries of what cars could do. They saw a problem, developed a solution, and believed in it enough to invest millions of dollars in countless hours of development. The tragedy is that sometimes the gap between theory and reality is wider than anyone anticipated. A suspension system that works flawlessly on a test track for a few thousand miles behaves completely differently when exposed to the chaos of real-world driving, harsh weather conditions, road salt, temperature fluctuations, and the wear and tear that comes from hundreds of thousands of miles of actual use. What's particularly interesting is that many of these failed technologies shared common themes. They often added excessive complexity when simpler solutions already existed and worked fine. They pushed the limits of available materials and manufacturing processes before those technologies were truly mature enough. Now, they sometimes prioritized impressive marketing over practical reliability, which is probably the most damning criticism you can level at any automotive engineer. And they frequently underestimated the cost of ownership, ignoring the fact that even the wealthiest car buyers eventually get tired of expensive repairs for minor issues. The good news is that the automotive industry learned from these disasters. Modern suspension systems are far more reliable than anything from the 70s, 80s, or 90s. The integration of better computer systems, improved sensors, and more sophisticated control algorithms has allowed engineers to create truly adaptive suspension that actually works. Systems like MagneRide, modern air suspension, and electronic damping control have benefited enormously from all the failures we discussed. They had decades of warning signs and failure data to learn from, which means engineers could design around known problems before they even started manufacturing. It's also worth noting that some of these technologies didn't completely disappear. They evolved. Air suspension, for instance, was an absolute nightmare in the early 2000s, but has become genuinely reliable on modern luxury vehicles. The difference is better materials, smarter computer control, improved sensors, and decades of refinement. What failed spectacularly in the Audi A8 of 2000 has been perfected in the modern Mercedes S-Class and BMW 7 Series. The core concept wasn't wrong. The technology just needed time to catch up with the ambition. There's a valuable lesson here for anyone interested in engineering or innovation in general. So progress isn't always linear, and sometimes the most expensive failures teach the most important lessons. Companies that are willing to try bold new approaches, accept failures gracefully, and learn from them tend to be the ones that eventually succeed. The manufacturers who pretended their failed systems never existed and tried to hide the problems were the ones who suffered the worst long-term reputation damage. Looking at today's automotive landscape, we can see the influence of all these lessons. Modern luxury cars still push boundaries with suspension technology, but they do so with far greater care and caution. Manufacturers now spend years testing new systems in extreme conditions, gathering failure data, and refining designs before bringing them to market. Its warranties are more comprehensive because companies know that even well-designed systems can have unexpected issues. And perhaps most importantly, engineers are far more willing to abandon a complex solution in favor of a simpler one if the data supports it. The suspension systems we use today in our cars are actually pretty remarkable when you think about it. They have to balance comfort and handling, accommodate extreme load ranges, work in scorching heat and freezing cold, deal with road surfaces ranging from perfectly smooth pavement to rocky off-road terrain, and do all of this while keeping passengers safe and secure. That's an incredibly difficult engineering challenge, and the fact that modern systems do it so reliably is a testament to how far we've come. Every successful suspension system sitting under a car today represents lessons learned from 1,000 failures, some of which we covered today. For those of you who own vehicles with some of the systems we discussed, my heart goes out to you. There's nothing quite like the sinking feeling when your mechanic tells you that your fancy suspension system is broken, and the repair will cost more than your first car. But take comfort in knowing that your experience contributes to the collective knowledge that prevents similar disasters from happening to future generations. Every failed repair, every diagnostic challenge, and every expensive replacement helps teach the industry what works and what doesn't. Thank you so much for spending this time with us, exploring the dark side of automotive innovation. And we hope you found this journey through suspension failure history as entertaining and educational as it was for us to put together. These forgotten technologies, despite their failures, are part of automotive heritage and tell important stories about innovation, ambition, and the challenges of bringing revolutionary ideas to life. If you found this video interesting and want to see more deep dives into automotive history, failed technologies, and engineering disasters, please hit that subscribe button. Your subscription helps us continue creating content that explores these fascinating topics that most people never think about. Drop a comment below letting us know which of these failed suspension systems you found most interesting, or if you've personally owned a car with one of them. We genuinely love reading your comments and hearing your stories. See you in the next one, and drive safely out there.